First, I should note that this talk is not very technical. It's more a story about how me and my friend who run this business, this not-for-profit, arrived at the solution of Kubernetes, coming from not a computer science background in any way. So it's more a use case and a kind of story into how we've applied this technology, or how we are applying this technology. So I'm going to start right at the start, when I was little, basically. So when I was little, I was never really satisfied with stock or vanilla, or like what standard things were that more people could have than just once. I always was looking for something custom and something bespoke. It started quite young, this feeling of needing to modify stuff, and I think it was about the age of 13, I started building computers, modifying computers and basically making them my own. So I built these computers, and on them I played games, and in these games I could customize characters, make places, etc. And I longed for this to happen in the real world. All of this was code, and it was easy to modify, and I knew that now, that it was a story, and a story that you could make up. The problem with it that I had was it was all locked in the computer. So I wanted the real world to be this customizable thing. The real world had been built millennia ago, it seemed, by people who weren't me, for people who weren't going to be me. But I was there, and I was forced to live in it. So I started looking at how I could work towards making my own places. So at the age of about 21, I found myself at university studying architecture, so that I could tick the box, say I was an architect, and then I could start building. At university, I learned a lot, but not really what the lecturers were hoping. So I learned that the course was really technologically not advanced. They were teaching a course from the 1950s. Moore's law goes pretty rapidly, and the course had long since lagged behind. No one was using, we weren't even allowed to use computers at all in the first year. It was all drawing. And it was taught really hierarchical, so that's where the architect is on Moore's law compared to the rest of the world. It was taught really hierarchical, so the architects at the top, they define this vision that they have that's all based on poetry and narrative, and then they impose their narrative down the line to eventually the building users get to use the building. And they're told that it is a success because the architects finished it. And very rarely buildings are revisited, and it's only real measurable successes that are. So there's a lot of problems with how buildings perform, in that none actually perform, or very few perform how they're expected to at the start. So you may know the walkie-talkie building, or the walkie-scorchy building that set fire to cars. I don't know if people know that, but it was a major design flaw of that building in London, and this happens repeatedly. So whilst on the course, my friend John introduced to me a program, or a plugin for a program called Grasshopper. I don't know if anyone's heard of it, but it's a node graph style visual programming thing, where you define a data pipeline, and then you get generated forms, and you can run analysis and generation and all sorts of computational things. So at the time, we were like, why aren't architects using this more? Because only a few really were, and actually the learning curves for all of this was really steep. So we started looking at what else was going on in the industry, and we eventually discovered this thing called BIM, which stands for Building Information Modeling. So this had actually been growing for about 15 years. It had been developing, and for everyone here, it'll actually sound really obvious as to how this progresses, because it is really the next natural progression from 3D CAD onwards using technology. But I'll give you a quick rundown anyway as to what it is and how it came about. So the old way of an architect working is an architect does a drawing, passes it to the engineer who makes a load of changes, and then passes it to someone else who puts their 2 cents in, and it gets moved about time and time again over many cycles between many people with many changes. And this like linear mesh of data flow is really hard to keep a track on. It's hard to keep accountability. It's hard to work out what's been changed. And it's basically just producing a lot of waste, essentially, a lot of lost time and lost money. Gradually, computing methods became more accessible. So 2D CAD was invented, which helped make edits to drawings better. 3D CAD was invented, so suddenly we can see these drawings which were really hard to work out in 3D. And then we get BIM, which is essentially 3D CAD with attached data to it. So each of the objects within that geometry model have attributes attached. The attributes can be anything, but they're typically costs, materials, things like that. So when you click on a wall in a BIM model, it knows it's a wall, it knows how much it costs, it knows what it's made of, it knows its dimensions, it knows who installed it, it knows how long it's going to last, things like that. So then we can use these models for simulation and analysis. So there are some big issues with this because they've got this whole concept now, BIM, but they still have these big issues. So how is data exchanged through this new model? What happens to IP? And what do we actually need to engage with BIM was the big question being asked for, by people. So how data is exchanged is one of the biggest problems, and this is an ongoing problem that's still here because actually we still exchange data in the same way. It's just rather than pass a drawing now, we just pass a file on a USB or something. And that's actually even worse because everyone has different modeling software, and so there's huge interoperability problems. So, I mean, we get like, it's all native, everything's native. So we're hoping, the industry hopes to move to the cloud soon where this gets addressed, but at the moment it's a big problem still. What happens to IP is a question bigger than technology, and we believe the building should own its own data. And what do we need for BIM is the big question because a lot of these companies were way behind with their technology, so they have really small computing teams and not good stuff at all, no software, and they have to spend a lot of money to get going. So we addressed all these things in a first company, BIMscript, which was a consultancy trying to bridge the gap between the technological world and the architecture world or the construction world. And we had a client come to us and say they want BIM because they need it. The government actually saw this as so vital that it's pushing it through industry. It's mandating its use this year. But they didn't want to spend any money. They didn't want to learn what it was, and they didn't want to change how they worked. So this was a big problem for us, or a big challenge for us, to come up with a solution for them which fit the bill, basically. So over the course of a year, we designed a web platform which we called the Bim Portal, which essentially was a collection of applications where they would send their BIM data and we would handle it back of house and basically serve up the data and the results of whatever simulations and manipulations there's run on it. It was in the designing of this that we started our journey into, well, basically this conference now. So we were designing this in such a way where we didn't want BIM to be like, a lot of companies were just buying big off-the-shelf solutions like by Autodesk, which were one-size-fits-all, big native programs with hundreds of features, and it was not bespoke to any client. And it certainly wasn't bespoke to any building or any use case. It was just a huge generic set of tools. So we wanted to create a more modular system where we could actually work with people to create tools which they actually levered the benefits of BIM and actually got the value out of it. So we started designing this system in a way where applications could be installed and run as necessary throughout a project. Then we started getting into the actual design of how these applications would be coded. Coming from no coding knowledge at all, this was. So this is just like us working through in our heads, how do we think we could get someone to code this? And we started designing these as kind of step-by-step modular pieces of function that we got from this Grasshopper precedent. So we were designing with this end goal of having this visual node graph-based data flow stuff going on. So the whole system is built of these interconnected modules, or the plan was to build it as such. And yeah, we released a prototype, which is that one. I would take you to it now, but I realized I don't actually have the password, unfortunately, to show you. But it's essentially just it's a selection of apps down the side, each running a different function for Bim. I could do, but I'm already... well, maybe if people want to see it, they can come and have a look at it, I suppose, after. So we had heard of this. We had designed this modular system. Obviously, a lot of industries had modular systems, and architecture was one which we were comfortable using this idea of modularization. It was in designing the prototype Bim Portal into the production thing that we were coming up with these problems, because the prototype was a monolithic PHP app with fairly heavy code-igniter framework based on this LAMP stack, and it was just a big and difficult thing to edit. So we eventually found out about things called microservices. It was actually, well, I mean, it was actually a time when we were at KubeCon learning about all of this stuff that we came up with this, sat in a coffee shop in Amsterdam, trying to work out exactly how to create these little boxes of code to link together. And that's when we were told by our friend Kai, who's just come in there, that this is not a new idea. This is something that's called microservices. And we were taught to treat each bit of code as a black box with an input and an output. And as long as the black box did what it said, as in the output was expected, which was all done via testing, it would be okay. And as long as they all spoke in JSON, which was the common language of the internet, then we could connect them together. So straight away, we were like, well, this is brilliant. We started operating test-driven development so that we could guarantee the outputs of these black boxes, and we started designing a new system. It was about this time as well that we realized that we didn't really want to have an opinion on what apps were on the platform. So we started a new idea, which was Jenca, which wouldn't be a set of apps that we had defined. It would be a platform which could accept apps to run at scale. So then the companies that we were working with could, or anyone we were working, any architect or designer in the AEC industry could come up with some application, and if it was a good application, they could share it and run it. So we set up Jenca, and the whole point of it is sharing innovations. It was actually a lot of research we did where we were finding development teams in big, like engineering companies would write a cool little script or a nice little program, and then it would be used on one project and never used again. So we thought we would create a platform to kindle and share these innovations, run them at scale, and set it up as a not-for-profit so that we could open this to this whole playing field. We would have no opinion of what the applications were. And then we went further into computer science. So we looked at the existing solutions for architects and engineers out there, like the Autodesk suites, which, like I said, were huge monolithic native apps running on Windows and basically filled with features, and they took a long time to learn and cost a lot of money to buy. It was basically like that, getting all your tools at once, and then you have to spend ages trying to pick through them and work out which one you wanted. So we were like, okay, how do we separate these out? We've got this good idea of microservices. How do we separate them out? So rather than have them all in one thing, why don't we wrap them in containers? And that's when we learned of Docker and the idea of creating this isolated environment for everything where things become immutable and things become easy to swap and change, and you can start composing your own versions of these big native softwares. So we also realized that open source is important. It's been a deciding factor on what technologies we ended up using, and we ourselves are completely open source. Everything is released on MIT licenses, so it's really permissive, and the idea is that everyone can join in and everyone can start building this. Yeah, so I mean, our realizing here was we were working with a company called the Bim server, which was one of the first open source BIM applications there was running on the cloud. And we could go in and look at their code, which meant it was trustworthy, and we could pull out functions and rewrite or like refactor into a better language, because they were a big Java app, which wasn't very good for this whole container thing that's going on. So how do we run this then? This is where Kubernetes comes in. We were thinking we could write these Docker files, we could start these applications up, but it was all manual. It was all, we have to spin a server up, we have to put these Docker containers on, we have to expose whatever port it is, and it just wasn't very good. So we started looking at orchestration, which is when we found Kubernetes, which fit the bill perfectly. Google Borg's use case meant it had a lot of confidence behind it, I suppose, with it being a good solution. The fact it was open source was really good. Its manifests are really simple in that I can write them and I can't code, but I can grasp exactly how they work and I can start putting them together. So we can offer a service to the development teams in the AEC world who don't even know about Docker, where we can Dockerize their app, write a manifest, and have it shareable and scalable in our platform. The service discovery is all done through Kubernetes. etcd and the raft algorithm keep Jenca self-healing and autonomous, which was fantastic. I mean, it's brilliant to know that if something goes down, it'll spin up again. It was easy to set up a development environment in Vagrant, or easy enough, I should say, which mimicked our production environment, which was in Google Cloud, which was really easy as well, because obviously they're coupled together. So just to recap on what the thing that we've built now is it's a place where users can go and create projects. Now those projects are kind of like namespaces, but even more so in that a user can have many projects. It's built to reflect a BIM project, a building project. Inside that project, they can put apps from the App Store or the app library. We are wanting to create this circular economy thing so that developers can monetize their apps and actually start gaining something out of sharing them as well. So you can select whatever apps you want from the store and then essentially press go. The apps in the store are encouraged to be written in microservices, so our entire platform is written in microservices. I will take you through it now. We have a GUI service, which was written in React and Redux, which is a really nice unidirectional way of creating quick load times for the user. Public routes through there to the router, which is the main place to send all of these requests. Non-public routes, authentication and authorization, obviously, which go always through first and then back to the router, which then goes to the other services. So we've got the project service, the library service, which is holding the apps in the App Store, and the runtime, which is starting and stopping instances in Kubernetes, and the cloud, which essentially glues all of this together. So then our intention is to create extra microservices, which are core BIM tools to help developers and people to get involved straight away with building applications for the built world, for the building industry. So the architect of the future needs to know more than just how to design a building based on this artistic narrative that they're going to impose on everyone. That's still important. It's important to have this bespoke feel, this design feel. They also need to know the environment and be able to run these simulations on it to test whether it will perform as it should. Forces and the community context, which we hope this platform will encourage as well, a sort of a community-driven effort on designing our built world. But in the future, we'll also have networked buildings and applications to interface with them. The buildings themselves will become computers, or computing will become ubiquitous through the building. So to relinquish control to few proprietary software vendors like Autodesk or ArchiCAD or Bentley or whoever to give only their opinion on what should be included in our built world seems ridiculous to us. It seems mad that there's this imposing monopoly of these people, and unskilled people in the industry are just being spoon-fed it. So the architect of the future needs to know how to also design the applications to run the building, as well as design and build the building itself. So that's our story as how we got to Kubernetes. Any questions about the, what's happened there? I think that's it. Yeah, any questions about anything about the architecture or anything, feel free to ask. The final thing to note is that we are a not-for-profit, and we're looking for collaborators to join in with this and to literally give any input that they can for the cause, because it's our built world, and our vision is that we can all have a say in how it's done. Yeah, so I think that's all I've got. So yeah, any questions?
Monetize the apps?
Well, the whole circular economy style thing means we want to put the ability for developers to monetize the apps. So yeah, I mean, it would be up to each developer whether they want to release it for free or monetize it. But the idea is to create this circular economy where we're encouraging developers to develop apps so that they can be rewarded for their efforts. Yeah. Okay.